Okay, so we're looking at how to apply the separation of variables method to solve a differential equation. So here we have a curve passes through the point 0, -1 and satisfies the differential equation dy dx equals y over 1 plus x squared. And we want to find the value of y when x is equal to when x is equal to 1. So how do we know it's a separation of variables question? Besides the large heading there, which would obviously not be there on an exam paper. We know it because we've got both x and y in our derivative. And this differential equation is separable because we can write it as a function of x times another function of y. Okay, so if we can do that, we can what we call separate the variables. We're going to basically move our function of y onto one side of the equation and leave our function of x on this side of the equation. So over here, if we divide by g of y, and then what's actually happening is we're integrating both sides with respect to x. Okay, so we're integrating both sides with respect to x. But what happens here on the left, if we can see, we're integrating dy dx with respect to x, which is equivalent to integrating over y. So that's, in a nutshell, the idea behind the separation of variables method. Now, if you're doing this question on an exam paper, you probably don't need to write all these steps. You probably just go straight to here, okay? Because we're pulling out y term on the other side and integrating. And for separation of variables method, this is always what we are doing in order to separate the variables. And we have a dy integral on the left and a dx integral on the right, which we would then need to actually work out. Okay, so if we have a look at this example, and I'll just pull up the work solution here on 10minutequiz.com. Okay, so we divide both sides by y, and 1 plus x squared stays on the denominator here. Then to integrate, integral of 1 on y is log y, or log absolute value of y. And the integral of 1 over 1 plus x squared is an inverse tan, and that's on your VCE Specialist Maths formula sheet. Of course, we need to add our constant plus c. Now, we would have a constant here from this integral and a constant from this integral. But if we've got a constant on this side and a constant on this side, we can combine them into one constant. So we can just write the plus c once. In order to find that value, we would sub in the initial condition, which was given to us in the question. And the absolute value of -1 is just 1. Tan of 0 is 0. So we would work out that c is 0 here. Okay, so putting this back into our solution which we had, we still have a modulus here. So modulus y is equal to e to the inverse tan x. And how do we know from this modulus that in this case y is negative? Well, we know because in the initial condition was 0, -1. So if we didn't have a negative here, that would not satisfy this initial condition. So we do need to check where when we have a modulus, do we want the positive or do we want the negative, or do we not know? In this case, we know that we want the negative. Also, if you remember, the question was asking for y when x is equal to 1. So we sub that in and get an answer of e to the negative pi on 4. Now, if we have access to our CAS calculator, which we would in our VCE Specialist Maths Exam 2, we can use the differential equation solver function. So we would go menu calculus and find the differential equation solver. And how we enter our differential equation, dy dx, we write as y dash. Okay, and that dash we can find under the menu where pi is. We write out differential equation in there in terms of x and y. Independent variable is x, dependent variable is y, and we also can enter our initial condition. In this case, we knew that when x was 0, y is -1. We type it as y bracket 0 equals -1. Click OK, and the calculator would then generate the solution for y. It works out the modulus, it works out everything. All we then need to do is plug in x is equal to 1 to find the value of y as asked for in the question.